These are solutions to Calc 1, Exam 3. So number 1, find the equation of the tangent line. So first we take the derivative. F prime of x is 3x squared plus 3e to the x. Plug in 0. F prime of 0 is 0 plus 3 is 3. So y minus y1, y minus 3 equals m3 times x minus x1, x minus 0. You could leave it like that, or a little bit of touch up, y equals 3x plus 3. Number 2, so quotient rule. So the first derivative is the bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the square of the denominator. Clean it up, 2x minus 8x squared plus 4x squared over 1 minus 4x quantity squared, or 2x minus 4x squared over 1 minus 4x quantity squared. Okay, the second derivative comes out real messy, so that's why we said don't simplify once you get to that. So once again, bottom times the derivative of the top, 2 minus 8x, minus the numerator, 2x minus 4x squared, times the derivative of the denominator, chain root 2 times 1 minus 4x times negative 4, all over 1 minus 4x squared squared, 1 minus 4x to the fourth. And you can just stop right there. Okay, number 3, also don't simplify. You have a product of 3 functions. So how about I'll count this as the first, and this is the second. So first function, x e to the x times the derivative of the second, derivative of the cotangent is negative cosecant squared x, plus the second function, cotangent x, times the derivative of the first, but the derivative of the first function is a product in itself. So I have to differentiate x e to the x, which is x times the derivative of e to the x, which is e to the x, plus second function e to the x times the derivative of the first, but the derivative of x is just 1. And you can just leave it like that. Okay. Number 4, horizontal tangent means derivative is equal to 0. So the derivative is 1 minus 2 sine x, set it equal to 0. That means sine of x is a half. So from trig, I want the y coordinate to be a half. That's at pi over 6 plus 2k pi, or 5 pi over 6 plus 2k pi, where k is an integer. Number 5, from the original, I'm going to force there to be a 5 in a denominator since I see the sign of 5x. So put a 5 here and a and sorry, I did this wrong. There should actually be another 5, not a 1/5. Should be 5. Okay, and that makes this a 5, and that makes this a 5, and that makes the final answer 5. So notice I just goofed there, but I think I got it now. So multiply top and bottom by 5, not 1/5. Okay, so take out the 5. 5 limit as x approaches 0. You can say 5x approaches 0. So limit 5x approaches 0, sine 5x over 5x. So that matches that, matches that. So that limit is equal to 1. So the answer is 5 times 1, or 5. So I just caught it now. Number 6. Okay, the derivative of sine is cosine. So cosine of cosine tan radical x. Okay, that's done. Then times the derivative of cosine, which is negative sine. So negative sine tan radical x, times the derivative of tangent, which is secant squared radical x, times the derivative of square root of x, or x to the 1/2. So that's 1/2 x to the negative 1/2. And again, you can just leave it like that. Okay, number 7, implicit differentiation. So we're trying to differentiate x, y, secant of x. So how about that's the first function, that's the second function. So xy times the derivative of secant x is secant x tangent x, plus second function secant x times the derivative of first, derivative of xy is x dy dx plus y times 1 equals the derivative of the right-hand side, negative cosecant y cotangent y dy dx. Now get all the dy dx's together. So first we distribute, that stays the same, but this is x secant x dy dx plus y secant x. So I'll subtract that over to the right-hand side. So the left-hand side does not have any dy dx's. It has that and that, leave that alone. But this side of negative x secant x dy dx minus cosecant y cotangent y dy dx, factor out the dy dx. I have negative x secant x minus cosecant y cotangent y. Divide both sides by this. And so your answer is the numerator, xy secant x tangent x plus y secant x, divided by this factor, negative x secant x minus cosecant y cotangent y. Number 8, logarithmic differentiation. Y equals x cosine x. Take the natural log of both sides. That lets the cosine x come down. Differentiate implicitly. The left-hand side is 1 over y dy dx. That never changes. The right-hand side is a product rule. first times derivative second. Derivative of ln x is 1 over x, so I'll write it as cosine x over x, plus the second function times the derivative of the first, negative sine x, multiply both sides by y. So dy dx is y, the original function x raised to the cosine x, times this extra factor, cosine x over x minus ln x sine x. Number 9, so I take the derivative, 3t squared minus 4t plus 5, plug in 2, and I get 9 coulombs per second, or 9 amps. Number 10, so I'm using a of t as a0 e to the kt. We start off with 100. After 1 hour, I plug in 1. I put 316 over here. Divide both sides by 100. 316 divided by 100 is 3.16 equals e to the k. Take the natural log of both sides. So k is natural log of 3.16. It's about 1.150572. So a of t is 100 e to the k, 1.150572 t. And now we're supposed to figure out what happens after 1,000 cells. So I plug in 1,000 to the left-hand side. So 1,000 is equal to all this stuff. Divide by 100. 10 equals e to the 1.150572 t. Take the natural log of both sides. ln of this just gives me the 1.150572 stuff. Divide both sides by 1.15, etc. T is roughly 2 hours, 2.00 hours. Okay, 11, we have PV equals K. I'm going to solve for V, divide both sides by P. So V is K over P, or K P to the negative 1, because I want volume as a function of pressure. Now differentiate with respect to time. dV dt is negative K P to the negative 2 dB dt, or negative K over P squared dP dt. So first I have to figure out the K. So they tell me I have 100 and 600. So that comes out to be 60,000. Okay, so I'm plugging 100 kilopascals for pressure, and the volume is 600. So K is 60,000. So dV dt is negative K. And then dP dt, they tell me is 20. And then the P was 100 squared, and it comes out to be a negative 120 cubic centimeters per minute. So the answer is that the volume is decreasing at 120 cc's per minute. Okay, number 12, to find a differential, dy is just simple product group. First, x squared times derivative of the second, derivative of sine 3x is cosine 3x times 3, plus the second function, sine of 3x times derivative of the first, which is 2x. So 3x squared cosine 3x plus 2x sine 3x dx. Finally, 13, just a proof, show that the left side equals the right side. So just by definition, sinh of x plus y means e to the x plus y minus e to the negative, there's a negative there, x plus y, which I can rewrite as e to the x, e to the y, minus e to the negative x, e to the negative y all over 2. Okay, sinh x is e to the x minus e to the negative x over 2. Cos y is e to the y plus e to the negative y over 2. Cos x is e to the x plus e to the negative x over 2. Sinh y is e to the y minus e to the negative y over 2. So I have a common denominator of 4. That's a 4. That's a 4. FOIL this out. So e to the x, e to the y, plus e to the x, e to the negative y, and then minus e to the negative x, e to the y, minus e to the negative x, e to the negative y. So these 4 are from this. And then continuing here, FOIL this out, plus e to the x, e to the y, minus e to the x, e to the negative y, plus e to the negative x, e to the y, minus e to the negative x, e to the negative y. Okay, and so I lined this up so that you'll notice that these two cancel out. These two cancel out. I have 2 of these. I have 2 of these. So I have 2 e to the x, e to the y, minus 2 e to the negative x, e to the negative y. Factor up to 2. 2 cancels with that 4, leaving with e to the x, e to the y, minus e to the negative, e to the negative y, all over 2, which matches this side here. Okay, so some of the problems were much more challenging. So again, there were 13 questions, 10 points each, but the grading is out of 100. Okay, so you had 130 points available, but it basically means 3 questions are sort of like extra credit. The maximum score is 100 though. So if you got over 100 points, your grade is only 100. But even though there's 130 points available. Right, so those are the answers to exam 3 for Calc 1.